Okay, good morning, everyone. So, for today, welcome back right after our long spring break and then finish your midterm. Okay, so we'll come back to our keep on doing some lab related to the and for today we will cover move on to some advanced um, stat, static analysis. Also later we'll cover more advanced dynamic analysis. Okay, and slowly just recap a little bit. When we talk about static analysis, then we just mainly analyze the code, right? So if you remember, so without really execute it, so we look at some suspicious files, and then we need to know how the programs really actually does, and then how it's structured, and then we try to looking for the behavior. Okay, so we are not really running it, but we try to looking for certain keywords, then some URL, okay, certain pattern, okay, structure. And for the more advanced, slightly more advanced, then we need to do the disassembly. Okay, so if we know the structure, when we writing the program, we most of the time we were just using the we call the high level language, right? So maybe people using the C++, and then but we need to know in the machine, we really machine we using the binary, the bit. Okay, so 0101 like this. 10, okay, and then slightly higher, that means the low level, or we say the assembly language. Okay, so it's slightly higher, and then goes higher from the compiler, and then um finally goes up would be our high level language. Then we need to figure out maybe those special patterns or signatures, and that's what we calling is called the reverse engineering. Okay, so binary. So we try to trace back because we want to know how exactly. So we call it assembly language. So if you remember in the lecture part, we talk about some what's the move as or try and move the register. So that will be that goes back to the really low level language. Okay, so that's what our reverse engineering doing, and slightly safe. So when we're doing the static analysis, so we are not really execute open it, and just looking for some hidden functionality. Okay, of first key code, and also try to set the check those memory in our control environment. Only one thing is just time consuming, and also you need to have some basic idea, programming concept. Okay, I'm not sure how many of you still remember the assembly language. So I try to prepare, and then when we dive in, then I will cover a little bit. Okay, what is the assembly language or something patterns we will see. Okay, and as well you know, because as well as the compiler, those compiler we need to convert the high level language. Okay, source code maybe whether we're using C++, or if you're using the Python, okay, or other JS, whatever, okay, so or Java, okay, so we try to convert them to the machine code, so the binary. So that's what the processor really understand. Then why we need to use it, or using the compiler? But compiler we try to optimize and transform the code, right? So which may affect really it for the analysis, okay. And also we need to know the compiler optimization, also maybe the function line, or how can we generate the binary code. So that's why it can be better helping us to doing the analysis, okay, the memory. And including three times, maybe we say the GCC, okay, GNU compiler collection. So also the C language, or the Microsoft Visual C++ or whatever. So all this may be possible. And I also mentioned another one is about the keywords called the assembly language. So assembly language, just related, really closely related to the machine code. Okay, so the bits, right? And it really depends on really specific to the computer article. architecture. And what you're looking, or like right now, how they're looking is like the structure is, of course, should be with Windows. Okay. And one it's so important. We need to like look at the assembly because the malware always say they will distribute as a compile binary. So that means like they are in the machine code or the assembly. So that's why we know it because they are all the executable files. And we need to know using the assembly language, which it can help the reverse engineer to analyze the exact behavior of the program. That's it. And when we look at the assembly language, of course, it includes different type of like register. Okay, those are small storage location. So you say EBAs, EAs like this. And then you will see some really common instructions. We always say move. Okay, the adding, subtract, jump. Okay, unconditional jump. Okay, and sometimes you will see in the we have the like stack. So those are the function calls, local variables they are putting in the stack. So, and then also the calling conversions. So how can they like calling receive the parameter return values? This is like we are going to like find okay in our assembly language. And those like CP instruction like we call the instruction, and they will including the move the data between the memory register, so maybe we'll see, and then the arithmetic operation, so adding, subtraction, okay, control flow, okay. So some keyword control flow will be like they will alter the execution, so including the jump or like some function call or some like logical operation, so including the AND or XOR those or the stack operation, they will like push or pull the data on the stack. So here's a pretty common example, or like the one you see maybe move the EX. Okay, so putting the 5 into it, so they will add it. Okay, to move the 5 to the EX register. That's how it looks like. And of course, we do have some like memory registers. So we say including a EAX is will be accumulator. So we're adding for the arithmetic or logic operation. Okay. So you see if you have something like using EAX, that means we of course for some accumulator. Okay, for correlation. And if you see the EBX, if you remember like EBX, the base of the address memory, okay, and then we're adding like base on this one. And then we have the ECX, okay, using for counter, okay, if this is some root operation, then you will see, okay, the ECX. And also EDX, and it will handle the data, so I'm mainly using for the IO operation, okay. So like this, and of course we do the stack pointer register like ESP and EBP. So if you remember like the EBP, we say we always going downward, okay, extending, and then you will see we using the EBP -4, +4, and then like more like -8 or +8 like this. Okay, so you remember. So with a base of stack frame, okay, and also ESP will be put to a top of stack. Okay, of course, we do have thread, register, some ICO thread, carry thread, okay, to hold the status of the thread, okay. And you will see a lot in our assembly example. We when you look at those like source code, we always move the EBX like to the value to the EX, maybe for calculation. So you when also you have an idea like safety of the arithmetic like calculation, okay. And stack, this one we just like recap. So what we say is a special area in our memory, okay, in your RAM. So we're using for managing function like call local variables, all those that return address. So all of them that we putting in this stack, and the maintainer is called the last in first out. Okay, so the last value I'm pushing on the stack, but the first one like being like pop up. Okay, and still need to remember we have the ESP and EBP. Okay, so which like pointing. So always say it's current step frame. So you will see the EBP is like keep moving. Okay, so it's a pattern. That's how it looks like. And of course, like if we have some function call, then we will giving the return address like push on the stack. So if you remember that time like when we talk, have some graph, right? So moving downward. And also for the function parameter local variable, also they will push onto this stack too. So that's how it looks like. When we try to like push, like if you see that push EX, that means we try to push the value of the EX on the stack, or like pop, then we try to like pop the value from the stack so into the EX. So this is how it looks like. And here giving you more example. So if you see the like assembly instructions, it will tell you, okay, when we try to see MOV, that means we are trying to move the data between the register or some like memory location. So or direct value, assign value to EX, or like moving maybe for after you calculate the value, then we need to like push it to the stack, passing the parameter EBX. Okay, that's how it looks like. Or for addition, okay, adding and the operand together, so value to the EX, or subtract. Okay, subtract the EBX from the EX, or like when you need to move a pointer pop, right? So if you remember, like EX subtract and then by 4, by 8, by 16. Okay, and also we can multiply the value. Okay, so if we multiply, so we just like directly like if you multiply which one EBX, that means like multiply EX. So because you know EX will be like by default for arithmetic and also a division. Okay, divide the value. So you can divide or jump. So you put a lot, you see lots of jump, okay, for the specific address. This one is called unconditional. So if you remember, like sometimes we jump equals or like some of the conditions. And of course, we have some like call function. So we push the return address and jump to the function and return. So we will pop the return address and then jump back to it. So far will be like this. And when we move on to talking some function, I will show you I will like to move on, show you our VM. Okay. Because right now we are just like doing the static analysis. So usually I still connect to the internet, and we said, of course, just like remind you one more time, if for dynamic analysis, or like even later we're doing the advanced dynamic analysis, remember to change your network, your machine network to host only. And if you remember, last time we connect to like, because we need to simulate, okay, pretend there's a network exists. So we will have another Ubuntu, okay, and running the service. So of course I do keeping, so pretend the service, and then we can use the Wireshark to capture. Okay, I'm not so sure how many of you able to like go to that step, and later I will let you. And when I try to install, because as what I say before the spring break, so I use a spring time to rebuild it. And just a few things, because I say for the Windows, for those like how do you create, I didn't really spend so much time, so I let you to do that. And just like I'm reminding you, because when we install the Windows 11, especially the latest version, it requires you to sign in your Microsoft account. And this is what you figure out. There's some issue why you like restart and then it couldn't sign into account. Remember the student acid. It really won't affect you, but you need to sign it by yourself, right? Here's the tricky part, because if you sign in using a PIN, And when you ask for the password, that's why like it's stuck over there. So you will see to account. Actually, there's some way to bypass it. Okay, so you can like when you choose to sign in your Microsoft account, you can using the I remember the shift function key F12, or like if using Mac would be like I think the function key and then like F12, and then you can like enter the command. There's a command help you to like bypass it. Okay, just letting you know. Okay, and once you bypass it using the CMD to bypass it, then you are not required to sign in your Windows account. Okay, so just remind it. So after you bypass it, then you can create your local account using your password. And after you execute the, if you remember the we want execute the install PS1. Okay, and you can successfully to restart and then log in again using your password. Here's a slightly tricky part of it. Okay, and right now just like be ready because we move on to our the lab. So for the lab, we if you I already put the slides. We talk about the memory analysis, and if you remember, like when we in the first part of like really beginning when we look at the lab, and then we have the static analysis, right? So we have the some like unknown exe. If you we know remember when we check the unknown exe file, actually we try to looking for the some like URL. Okay, so they try to connect to a domain and then like slash with a favicon. Okay, so favicon. So once they detect the connection, and they will be able like connect, have an internet and access to it, then it will try to execute. Okay, but if this malware like detects that there's no network connection, okay, so they will delete itself. That's like is a tricky part of it. And for the advanced, we need to use one application. So this one is called the cutter. So we are going to use the cutter. So I would like to let you, and please let me know if you have this application or not, because I already started. So if you are first time open it, so it will have settings. I'll say, do you agree with it? So you can click on it. Okay, and let me try to check my screenshot and make sure it's the screenshot I'm using. So I make sure I have a screenshot, then all good, save. And in this process, so of course, as a basic and static analysis, we always check like maybe the checksum or like using like submit it to the website like what's total. So if you remember, okay, and looking for some pattern, and for this part, same. Okay, so we infected. So I put this file to the desktop. Okay, and so we just like pull it out, and then we will open it using the cutter, and then pass it. Okay, I forgot the. Okay, so it turns on the antivirus. Okay, if you follow the guideline, here's like one thing I need to remind. Even there's a group is like you can turn off the your antivirus like as a group. If you, okay, I think it's already blocked. Let me try to put it back. Protection history. And let me unzip it one more time. So if you're following or doing it or checking, then you can we can do it together. Let me put it to desktop one more time. Okay. As we try to remind you, we have the good policy, or like you can using the command R if you like register edit or wherever you can like search it, and there's a configuration we need to change it, and under the our system Windows, let me see. We can because you know the antivirus, the defender always like turn on. Okay, right here, status like we always like turn off the real time and then the dev driver protection, right? But also it contains the cloud deliver protection or automatic sample submission. And this one we can turn it off using the registry right here. And let me find where is it. Where I just forgot which directory. So let me go back to. And right here, if you remember, like we have the term protection. So right here, there's some links and lines. So we're telling you. Of course, I also do it by myself and try to edit. So remember, you need to turn off the Windows update policy, and also maybe like some like policy group. So real time. It telling like you can like edit the Windows, go to the terminal by yourself, or we can use the gedit and then share it. So it's under the okay, configuration administrative template component Microsoft. So we can using the gedit. Under the good policy right here. Okay, so it's not the same because I'm working on the register, but it's the should be the good policy and good policy. So you can follow this link and then go to like computer configuration. It's right here, and then the administrative template will be right here. Okay, and we have the Windows component, and we will see the Microsoft Defender antivirus. So we just click on it right here, and then Windows component. And what you need to find is the Windows Microsoft Defender antivirus. So we need to find where's the Microsoft antivirus. Defender antivirus, and you will see there's a called a ton of Microsoft Microsoft Defender and the antivirus, and then you can like change it to disable, and this you need to like apply okay because I already turned it off, but the real time is still like turning on, so we need to like change it by ourselves, and then you can follow the instruction. Okay, and for today's, we mainly will analyze these files like using called a cutter. Okay, so we're using cutter, open these files, open, and once you choose open, by default, like for analysis, we're using the auto, and then we don't have to like change it to anything, and just like by default, and we can click OK. Okay, so once you use the cutter to open this file, so it will try to like it may not exactly the same as the like when because we're doing the reverse engineering. Okay, so we already have the library from the executable files. Okay, and then we try to look at all this. When we double click, open the files, dashboard, and like for the dashboard, it will show that some all of the some basic information if you remember like the class, IP32, and then including the hash like MD5 SH1 256. So here would be like what we need like looking for the static analysis, right? And right here, if you click the disassembly, okay, so when you check the disassembly, and you will see all the like they have some other memory location, and with the different move like the push, okay, you will see if you remember you say push like EBP, okay, move the ESP to the EBP, okay, and then some value, and this is how it looks like. So all this will be like start with the entry point, okay. And one thing is like pretty nice is the graph. Okay, so this graph is telling you they will break down. Okay, so Bill we talk about different type of like um jump, right? Unconditional jump, go to different um address, different location. Okay, and after they finish, maybe they will maybe return, or like they would go to another set of the statement. So you see maybe like if they have a jump condition, go to another memory address, and then after they like execute certain um, um, operation, then maybe they have another connection. So is this one is jump equal like JE, and then they will jump to another one. So this is a really nice like graph showing like all the steps. And when we try to look at it, um, we will mainly go to the main. So you know the entry points like when we with the execute. But if you remember when we writing program, we always have main function, right? So the main function includes everything. And for this cutter, we're going to check the main function. So as a basic information would be it should be the same like basic information. And when we go to disassembly, okay, disassembly will be look like pretty similar. So we will try to move the EBP. Okay, and so you see the structure if you remember like EBP structure. And what we are mainly looking for, just like help you like because some memory like what we're looking. So because we say this malware, we try to check the network connection and try to access. Okay, so to access to the URL, the favorite con, right? So if it able to create a connection, then it will start to like fetch certain data, install it. So right here in the main function, then we're going to like check and try to find if there's a URL like exists, and also check the favicon. So see. Okay, so if you're following, if you are like doing right now, then you can look at it, and also you can check the graph. And then if you remember, we have the DWORD, right? We have the URL tunnel. And if we are able to like tunnel, and if we not able to tunnel, and we like if we have the jump not equals, so if you remember, like if we didn't receive anything, so in this part maybe we just like finish and return. If you see the return, so that means we are like the itself. If you remember, we have a ping. So ping 111 would be like checking the network connection, and then also we try to check the user public documents. So right here, and also if or nothing, then if something, if we compete, then also we will like end of it and stop execution. So maybe here, so will be the graph of this main doing. This is the beginning. So if we have the core keyword like URL, and then we try to have a test, and then checking the EX jump, and with the ping, like push this one and try to create the CR43310 like dot date dot exe. So right here you see from the able to find in the assembly. Okay, and then go back. Okay, so when we see some like functional calls, so when we talk about, so there's some like some stat operation. So we have the functional prolonged. Okay, so they will be like pushing to the EBP, or like we need to like save the base pointer, and then maybe we have some like some set the base pointer for some local variables, then we'll move it. So the ESP to the EBP. And also in the function body, so we can like check if there's a EBP, like move, like adding the first parameter. So we use EBP plus 8 to the arithmetic, and then or like adding the value to it, something similar. Okay, or the function this the epsilon. Okay, so they will like maybe clean up the stack. So they will move the EBP back to ESP, and also we store it, pop it out using, we store the old base pointer, and then return the function. So you will see in the assembly code. So of course we have some return, and then move the EBP, like when we try to execute. So when you're looking for this detail, so maybe you have some idea. And also when we look at the assembly code, and also we need to find some values, like or some like some key keywords, or like some URL paying. That's what we always need to check, because all these like malware, they always check the network connection. Their files is pretty small in size, and then after they validate the network connection, that means they make sure your no matter your VM or like your really desktop, okay, environment, they do have a network access, then they will like go to certain, perform certain action. Or like if they after ping it doesn't work, then they will just like delete they set, like pretend they're not exist anymore. So that's why we are going to check. Okay, if we say move, clean the EBP, pop, and then return. So that's why we're here. Okay, and this is how it looks like. And like in the beginning, in the main file, sometimes we try to create some variables and moving. So you will see that's why right here, the call return in the EBP. So how is the pattern looks like? And for this time, we have like different type like static mail and access tool like for this one introduced. This time we are using the cutter. So this one is pretty nice platform. So we can make it like we can use within useful using a design assembly for slightly advanced level, integrate the debugging, scripting support, all this. And but when we're doing the advanced like analysis, we need to like obfuscation like detection. So we need to like maybe some encryption packing, some code obfuscation to hide the behavior we need to check. And later when we move on like from static to dynamic, then like this time we don't have to really execute, but you look at the dynamic. But this time for advanced, then we will check like when we execute this file, how it change in the memory. Okay, how does it really perform? And for today's let me just like catch up from our long break. And at least like for this step, you should able to let me make it smaller for this one. Okay, and then switch back. And you should able to open the cutter and check all this and try to like find all those like key right here. So how to start the paying, and then we try to looking for the favorite con. So that's why we need to find. And let me go down a little bit. So let's see, because I couldn't find it right here in this moment. But in the graph, we were able to from the entry on the graph, you see the domain, like the favicon, but this time I couldn't find it right here. So if you're able to see it, then okay. Oh, let me see that. Okay, right here. Okay, I forgot the decompiler. So the decompiler we change it. So this one may it looks like similar, but maybe not with the C or something. Not exactly the like really high level language, but this one will be like looks like more like high level language is easy to read. So there's a main function, and you try to like say the variables like EX and then ECX like counter. And you see if you see the URL download to files, right? If you remember, we try to like access this domain and then try to get the favorite account. If we're able to that's like what it push to their move it to the EX, and also including the CR433.101.date.exe. So they are mainly these are two type of file. One is the URL, and another one is the exe file. And we need to search, and then in the shell we try to ping, like we try to check if this part like it exists. Okay, so if it doesn't exist, then it will try to like create the file, delete itself. So that's like it's mainly these files like perform. Okay, so it's mainly right here. So it try to get its the applications, so it will able to find where is it. So no matter where you put the file, no matter it's under desktop, download, or like some nested folder, so it will still get able to get the path and then delete itself. Okay. So this one is called the decompiler, and this will be found will be under this right here. So this is assembly and then the compiler. So where we're going to check. Let me how you stay right here. So we have 6 students. I'm not so sure how many you like waiting here. Are you like following and try to open the file and check it? And if yes, then I would like to let you to do it right now. That's your time. So we have some time. So it's like more time. So I will let you to check this file. And if you have any question, feel free to ask me like for some settings. And as a comeback, like we of course like we have a new assignment, so will be related to all this. So you need to like using the cutter, okay, to like check all these files and then looking for like after you pretty easy. Just like at least I know you are following and doing like all the work. Okay, so at least you will use the cutter and then able to check the dissembly and then looking for the compiler, and then we try to find like figure out which there is some like malicious like some content we using this one, so including the decompiler or like telling the logic right here or the graph. Okay, so we go to main and then we see in the main, so if we able to find the network connection, and then we're gonna execute like try to ping. Okay, so like this part. And of course, like for the assembly, you see something like handle with the kernels, like a lot API. So others like if there's some one thing you see assembly graph. So we have pretty a lot compared to the entry point. Mainly in the entry point, you see because we have lost drum and like returning different status, and then like push it from the memory. So you see this one. Okay, so I will just like mute it, and I will see how many of you are following. If you are able to do that, then yeah, I will see how many of you are staying or like asking question or doing. Then when it's your time, I will mute myself. As reminding you, because we are doing the color static analysis, right? So when we doing a static analysis, that's like a maximum of we can see, or like looking for some URL, or like for some exe file. But because we still not yet execute it, okay. So it's like we calling when we did the basic dynamic analysis, we change it to exe file, double click, execute, and then try to connect the Ubuntu. Okay, so we try to simulate. Okay, let's see, to simulate the network. So after it like able to like ping and then create the get the network, and then we try to create the exe file and pull the data. Okay, so that's like what this malware doing. And of course, because I just like pay my keep in mind in this moment, because we're doing static. Okay, so that's why in this file it like includes some maybe some like kernels like basic, but so far everything will be the core will be this part. So you just need to check that the compiler in the main, and then that's all the core information. Okay, and you should able to find all this content right here. Okay. Let's do some student right here. So I'm checking. And after the class, I will see when the all this video available. So after class, I try to upload. So I will post the YouTube link. So like based on the week 1 to week 8, or even like come back from today. So I will try to like update more frequently like this. So you can watch it for other students, and I also will post the YouTube link. Okay, today. So but so far all the videos, so they're all available. Okay, so if the student that you already have my YouTube channel, and you will be able to find all this. Yeah, in the beginning, I think like some student not only this course but other course, like I try to record it, like sometimes I try to record it, and then actually you are able to find from the cloud. Okay, recording. Okay, but I feel like maybe some students not going to check it, so that's why I try to like update more like frequently, upload it to YouTube. Okay, and I will mute myself, and let's see. And I will wait, stay here slightly, maybe 10 to 15 minutes. I will wait a little bit, and let's see if you have any questions, or no matter like using the cutter to check the information, or you need to set up your VM, like make sure all the environment, or like you miss it, then if you don't have this application, then also you can download it. Okay, so all the like technical issue you're facing, then you can let me know. I'll mention myself again.
So the rest of the class time is just trying to see if you got that right, sir.
Yes, yeah.
Still in the middle of downloading it, so I haven't quite caught up. But yeah, if the rest of the time is just lab stuff, then I'll just work on it offline.
Yeah. You can go offline. I know it may be taking your bandwidth. Okay, so you can go offline and then download it, install it. Okay, if you need to do by your own.
Right.
So you feel free to leave. Yeah. So I just like helping you for the rest time your own lab time. Okay.
Right. Thank you, Professor.
Okay. No problem. Okay. Have a good one. See. Okay. If there's some student they are leaving, then I just end this meeting, so you can spend your own time install it, like if for all those like required application, and remember to install it, and that at least you should able to get this part. Okay, and then I will end the sharing right now. Thank you. Have a good one.